Welcome to this video. Today we talk about basic chemistry, states of matter. What is matter? Matter is whatever occupies space. Whatever we see around us can be classified as matter. Heat, light, etc. are not classified as matter. Matter can be classified as elements, compounds, and mixtures. Matter can be classified as solids, liquids, and gases. Now, the solid, liquid, and gases are called the different states of matter. Now, plasma and Bose-Einstein are also certain states of matter which can be found only under specific conditions. Now, this matter can be changed from one form to another. For example, solid, liquid on solidification becomes a solid, that is, water becomes ice, and solid on fusion can become a liquid. Likewise, solid on sublimation becomes gas, like camphor, or gas on deposition or desublimation becomes a solid. Likewise, liquid will become gas on vaporization, while gas or water vapor will become liquid on condensation. So these happens because of various physical and chemical properties of the atoms in these elements which form these compounds or elements. Elements, the simplest substance which cannot be further simplified without chemical or physical means. Now, compounds are combination of one or more atoms of one or more elements which exist independently. They are compounds. Molecule is the smallest indivisible part of a compound. Atom is the smallest indivisible part of an element. Now, these atoms and molecules are of very small sizes, very small sizes. So, when we look at the size, we have atomic mass unit as 1 into 10 power minus 27 gram per atom. That is the weight. If you look at mass, it is 9 into 10 power minus 31 is the mass of electron. For proton, it is 1.6 into 10 power minus 27. Neutron, it is 1.6 into 10 power minus 27. These are the very small sizes on which the atoms or the elements exist. 1 atm is for atmospheric pressure. Barometer is barometric pressure. While angstrom is 10 power minus 10 meter. This is size of an atom. Within this 10 power minus 7 meter, we have electrons, protons and neutrons which are 10 power minus 31 kilo as a mass. Right? What is a melting point? Melting point is the temperature at which matter converts from solid to liquid. Now, melting point decreases in the presence of impurities. So, melting point is temperature at which matter converts from solid to liquid state. Boiling point is the temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure. Boiling point, vapor pressure becomes equal to atmospheric pressure. That is a point at which the liquid molecules or the particles that form an matter, when it is in solid, they are closely packed. When it is in liquid, they are not as closely packed as in solids. And when they are in gaseous state, they are freely and randomly moving around. So what happens is when you heat, when the temperature increases, the particles of the liquid start moving, start agitating, and then they create a pressure. When this vapor pressure becomes equal to the atmospheric pressure, it is called boiling point, because at this point, water will start becoming vapor. This boiling point increases in the presence of impurity and the rise in pressure. Melting point decreases in the presence of impurities. Boiling point increases in the presence of impurities. What is a freezing point? Freezing point is the point at which a matter converts from liquid state to solid state, or water becomes ice. What is evaporation? It's a conversion of a liquid into vapor. That is why when you heat a glass of water in a kettle, after half an hour you will find no more water left. All of them would have evaporated. That is why ponds and lakes become empty in summer. The water droplets appear on the outer surface of a glass containing ice cold water. This is what? This is the vapor in the atmosphere is becoming liquid because of the cold water in the glass. Water kept in an earthen pot becomes cooled during summer. The water becomes cooled because the earthen pot is having pores through which the movement of the vapor or the heat happens. What is plasma? We have seen solid, liquid and gas, and then two things called plasma and Bose-Einsteins. What are these? Plasma is a matter similar to gas in which a certain portion of gaseous particles are ionized. Plasma is super hot and super excited. Plasma is similar to gas, but it is super hot and super excited because some particles are ionized. What is ionized? It becomes ion. What are ions? Cation and anion. What is cation and anion? When an atom of an element loses an electron, or when an atom of an element gains an electron, it becomes negatively charged or positively charged. When it gains electron, it is negatively charged because one electron extra, it is negative. When it loses an electron, it is positively charged. That is, one electron is lost, one negative charge is lost, so it becomes positive. Why? Normally, atom is neutral because of the number of electrons and number of protons. The number of negative charge and the number of positive charge are same, and so it is balanced. So atom is neutral, but electrons are negative, protons are positive. So when electron is lost, it becomes positively charged. When electron is gained, it becomes negatively charged. These are ions. So ionized gas particles, when it is super hot and super excited, it is called plasma. On Earth, plasma is naturally occurring in flames, in lightnings, in auroras. What are auroras? In the northern and southern hemisphere, you will see auroras because of the natural phenomena in which the atmospheric air and the gases in the atmosphere, along with the particles of light from the stars, reach Earth in the form of beautiful lightnings in multiple colors. What is plasma occurring in flames and lightnings? In flames and lightnings, because of the heat at which the light particles are spread out, we can see the plasma. But normally, otherwise, plasma is not found on Earth, but found a lot in the universe, in the outer space. What is Bose-Einstein? Bose-Einstein is something special. It is called Bose-Einstein because the name is given to give due respect to Satyendranath Bose and Albert Einstein, who were instrumental in identifying and discovering this particular thing, Bose-Einstein condensate. This is a gaseous superfluid phase formed by atoms cooled to temperature very near to absolute zero. Now, when it is super hot and excited, it is plasma. When it is super cool and unexcited, it is called Bose-Einstein. Now, we are talking about a temperature which is near absolute zero. We cannot normally go below zero, near absolute zero in normal lab conditions. This was produced by Eric Cornell and Carl Wienemann, but it was predicted by Bose and Einstein. That is why it was given by their name. Now, what are intermolecular forces? The intermolecular forces are the forces that attract the molecules or the atoms of a solid, liquid or gas to keep them together without flying off. Without these intermolecular forces, the matter will not exist in any of these states. Now, in solids, they occur in the form of lattices. Now, intermolecular forces are attraction. Now, something that we have something called van der Waals forces also. Now, greater the intermolecular force, higher is the melting point and boiling point. Greater the intermolecular force, higher is the melting point and boiling point. Now, there is something called dispersion forces. What is that? It's also called London forces. They are present among non-polar atoms and molecules like chlorine. They are the weakest intermolecular forces. That means what? Dispersion forces doesn't help to keep the molecules together, but may help to spread the molecules away from each other. That is why they are called weakest intermolecular forces. Then we have a dipole-dipole interactions. In the dipole-dipole interaction, what happens is the forces act between molecules possessing permanent dipoles like HCl. Now there are hydrogen bonds. Hydrogen bonds are one of the most important bonds in compounds. NH or OH or HF bonds, these are highly polar bonds which keep the compound as together in the molecule or the atoms. What is thermal energy? Thermal energy is energy that you get from the heat. Energy of the body arising from motion of its atoms or molecules is the energy. Now, what is the energy caused? Energy is caused by the movement of the atoms or molecules. What are these movements? These are continuous vibrations. These are agitation or continuous vibration. Now, the electrons in an atom are in continuous motion. They have an orbital motion and they have an oscillatory motion. So the electrons, like Earth rotates or spins on its axis, and like Earth goes around the Sun, the electrons spin around themselves as well as they go on the orbital path on their shell around the nucleus. Now, this also causes vibration and agitation, which gives energy to an atom. This is a thermal energy. Now, this is proportional to the temperature of the molecules. It means what? When you heat something, when you heat ice to become water or when you heat water to become vapor, when heat is added, when temperature is increased, the thermal energy or the vibrational or agitational energy of the molecules changes. Why? In the gaseous state, the forces of attraction is reduced by addition of thermal energy. In a liquid state, the forces of attraction are more when there is a thermal energy. In a solid state, the forces of attraction increases further when there is a thermal energy. That is why when you heat an ice cream, it becomes liquid faster than leaving it on a room. So the attractive intermolecular forces are called van der Waals forces, but in the presence or absence of thermal energy, these intermolecular forces will lose their strength because of the vibration or agitation in the molecules. Why? When you add heat, the vibration or agitation increases. That means the thermal energy increases. Gaseous state is the most disordered state. In earlier basics, we would have studied solids are having a definite shape because the molecules are firmly togetherly arranged. Liquids, they have volume of or shape of the container. They have shape of a container because the particles are not as closely interlocked and arranged as in a solid. In gas, they do not have a definite shape. They do not take the shape of the container, but they expand to occupy all the space available inside the container because the molecules are loosely packed. That is why gas is the most disordered state of matter. The intermolecular forces are weakest. The intermolecular forces are weakest. They don't bind themselves together, but they are as far away, as stretched as possible space available in the container. They are highly compressible because they are not having a fixed intermolecular shape giving structure. They can be compressed. The gases are highly compressible and then they exert pressure in all directions. The intermolecular forces of a gas exert pressure in all directions. That is why when you fill a football with whatever gas or air, the pressure on all sides of the ball, the sphere, is the same. They have lower density than solids and liquids. Gases have lower density than solid and liquid. Because they have lower density, gases are converted into liquids when you are transporting to a long farther distances. For example, the LPG, the LNG that are shipped from the Middle East to various countries are usually gas to liquid, converted into liquid and transported and then reconverted into gas. The volume and shape of gases are not fixed. Why the volume and shape are not fixed? Because the molecules are weakest and because they are compressible and they exert pressure in all directions, they move in all directions and occupy all the space available on the container. And so, gases mix evenly and completely in all proportion without any mechanical aid. They mix evenly and completely. These are the specialties of the properties of the gases. Mass of the gas is measured in gram or kilo. Volume is measured in volume of the container, 1 liter container or 1000 centimeter cube, that is 1000 cc, that is ml. That is ml. 1 meter cube is 1000, 10 power 3 dm3. Dm3 means what? Decimeter cube. Decimeter is what? Decimeter is nothing but um, 10 power 3 when you convert to meter, or 10 power 6 when you convert to centimeter, or 10 power 3 liter is 1 meter cube. 10 into 10 into 10 liters can be put inside 1 meter cube. That is how we measure the volume. Now, we measure volume in the form of a liter when you pour something in the container. But when you put something in the form of a box, you can create a cube of 1 meter into 1 meter into 1 meter where you can have the fluids measured. Pressure. Gas pressure is measured using two instruments. Manometer is for gas pressure, while atmospheric pressure is called barometer. When it is a specific gas, you can have a manometer, but when it is a mixture of gases in the atmosphere, it is barometer. It is force per unit area. Pressure is force per unit area. ATM is the measure in manometer, while for atmospheric pressure barometer it is 10 power 5 Pascal. 1 ATM is 1.01 bar. 1 bar is 10 power 5 Pascal or 0.987 ATM. It is 76 centimeters of mercury. 76 centimeter of mercury, or we say 760 millimeter of mercury. 72 milli is 10 times more. 76 becomes 760. Or torr. What is torr? Torr is millimeters of mercury. Hg is mercury. What is standard temperature or pressure? It is called STP NTP. 273 Kelvin is called the standard temperature, which is 0 degrees. 273 Kelvin is 0 degree centigrade or 0 degree Celsius. And 1 bar, which is 10 power 5 Pascal. 1 bar is 10 power 5 Pascal, is the pressure. What is molar volume? Molar volume of an ideal gas is 22 liter. 22 liter per mole is a molar volume. Again, mole, we know how do we measure the mole. What is Boyle's law? There are certain laws which impact the gases. Boyle's law says volume of a given mass of gas is inversely proportional to pressure. Volume is inversely proportional to pressure. Volume is inversely proportional to pressure. This means what? If you have more volume, it is less pressure. If you have less volume, you will have more pressure. Inversely proportional. Air difference at sea level, because it is compressed by the mass of air above it. Because the atmosphere is compressing or putting pressure on the air just above the sea level, it is dense. Why it is dense? Because volume is less. Because of the pressure, it is pushed down. So volume is inversely proportional to pressure. What is a graph? It's a pressure versus volume graph. So as pressure comes down, the volume increases. As pressure goes up, the volume decreases. Then you have a PV graph. At constant pressure and 1 by volume. When you have the inverse of volume, it is a straight line. This pressure volume graph are called isotherms. Pressure volume graph are called isotherms. Now pressure into volume, because pressure and volume are proportional. When pressure and 1 by volume is a straight line, pressure into volume at a temperature 1 is a straight line, pressure into volume at temperature 2 is another straight line. At different temperatures you have different straight lines, PV to P graph. So these graphs are called isotherms. Charles' law. Charles' law says volume of a given mass of gas increases or decreases by 1 by 273 of its volume. The volume increase or decrease by 1 by 273. Volume of a given mass increase or decrease by 1 by 273. For what? For every degree rise or fall in temperature at constant pressure. CTP. So if the pressure is constant, the volume will increase or decrease for every degree change in temperature. So at 0 degree, this will be the thing, and then as the temperature goes on increasing, the volume will keep on increasing. As the temperature keeps on decreasing, the volume will be on the negative side. It is getting compressed. Minus 273 Kelvin is the maximum you can reach, because 273 1 by 273 is the proportion, and 273 Kelvin is what we have seen as the standard measure. 273 Kelvin is the standard measure that we have seen. This is only Charles' law. The volume of a given mass of gas increases or decreases 1 by 273 of volume for every degree rise or fall in the temperature at constant pressure. This volume versus temperature graph is called isobar. The pressure versus volume graph is called isotherm. Then we have a Gay-Lussac. Gay-Lussac said pressure of a given mass of gas increases or decreases by different pressure for each degree rise or fall of temperature at constant volume. This is change in temperature at constant volume. This is change in volume at constant pressure. Charles said change in volume at constant pressure, and Gay-Lussac said that pressure will change for every degree rise or fall in temperature at constant volume. This is temperature and this is change in temperature at constant pressure. This is change in temperature at constant volume. Now, this graph is called isochore, pressure and temperature for volume 1. This is for volume 2. At a constant volume, at each constant volume, this will have a different angle. Now comes Avogadro's law. What does Avogadro say? He says volume of equal volumes of all gases under same temperature and pressure, under STP or MTP or normal temperature and pressure, on the same temperature and pressure will have equal number of molecules. Equal volumes will have equal number of molecules. That is why we have something called Avogadro's number, N and suffix A, Avogadro's number. And molar volume is 22.4 liter. What is molar volume? Volume of 1 mole. Volume of 1 mole is molar volume. PV equals to nRT is the ideal gas equation. P is the pressure, V is the volume, N, R is the gas constant. R is the gas constant. T is the temperature. R is the gas constant. So in an ideal gas equation, PV equals to nRT, R is known as a universal gas constant. Now, density is Pm by RT, where M is the molecular mass. M is the molecular mass. So what is the R? What is the universal gas constant? It's a number which can be referred in many ways. One of them is 0.08 liter per ATM, atomic mass, per mole per Kelvin, 0.08. Or it can be measured as 0.083 liter, and the unit is barometric pressure. This is manometric, this is barometric. Or in the form of energy, it is joule per Kelvin, 8.3 joules per Kelvin, or 8.3 into 10 power 7 erg. Why? 1 joule equals to 10 power 7 erg. So joules per Kelvin per mole, or 8.3 into 10 power 7 erg. Or it can also be measured as, for every erg we know how much calories is there. So we know 1.9 calories per Kelvin. 1.9 calories per Kelvin is the gas constant used in PV equals to nRT ideal gas equation. Now none of the gases present in the universe obey this PV equals to nRT formula. That means none of the gases are in ideal state. Real gases behave ideally at low pressure and high temperature. Real gases behave ideally only at low pressure and high temperature. So when T goes up or when P goes down, it will have a PV equals nRT formula compliance. Otherwise, gases are not at ideal situation. What is Graham's law of diffusion? It says under similar conditions, the rate of diffusion of gases are inversely proportional to square root of densities. Rate of diffusion is inversely proportional to square root of densities. What is density? Density is mass per volume. So what is this diffusion? Diffusion is a tendency of the gas to distribute uniformly throughout the available space. Distribute uniformly throughout the available space. What is another behavior like a diffusion? It is called effusion. What is effusion? EFFUSION. It is a movement of the gas through a small hole when subjected to pressure. So when a cycle tube is punctured, the gas comes out. That is effusion. That is not spreading. It is coming from a high pressure area through to a lower pressure area. Diffusion is spreading of the gas to all the available space uniformly on its own throughout is called diffusion. This is proportion to the density. What is density? Square root of densities. Density is mass per unit volume, unit area. What is Dalton's law? Dalton's law says at constant temperature, the total pressure exerted by a mixture of non-reacting gases is sum of partial pressure. So if you have oxygen, hydrogen, oxygen like an atmosphere, they all have their own densities, their own temperature and pressure. And the pressure exerted by the atmosphere will be equal to pressure of hydrogen plus pressure of oxygen plus pressure of nitrogen plus pressure of carbon dioxide. Why? Because they are not reacting with each other. They are remaining as a mixture. If they react, something else will be formed. This is Dalton's law. What is partial pressure? It is a mole fraction of the gas into total pressure. Mole fraction of the gas into total pressure. Total pressure is overall pressure by the gas available there. Partial pressure is a pressure by mole fraction of the gas. Now there is always a deviation from ideal gas constant. PV equals nRT does not form. This deviation is from the compressibility factor. What is compressibility factor? Compressibility factor is called Z. That is how much it can be compressed. Now in gas theory, just like we have seen the thermal effects of gas, let us look at the kinetic energy. Now volume occupied by the gas molecules are elastic. They have very weak intermolecular bonding. They are very far away from each other. This volume occupied by gas molecules is compared or negligible when you compare to total volume of gas. Why? Because the volume will be based on the container. It will expand to the whole of container. So gas occupies that container may not be a right statement to say because that volume is negligible compared to the total volume of gas. What is total volume of gas? Total volume of the gas is the gas into which it can be compressed by pushing the molecules to go closer to each other because they are elastic. The continuous rapid random motion of the gas molecules at different velocities will cause collision. Continuous rapid random motion of the gas molecules at different velocities will cause collisions. Now, because there are different collision and at different point in time, electron may go and hit another electron, electron may go and hit the nucleus, electron may go and hit the empty mass between the electron and the nucleus, the collision will cause different types of energy. But there will be no loss of energy. Now, we have seen in the thermodynamics that there is a heat because of the continuous rapid vibration of the molecules. Now, when these gas molecules go and hit another gas molecule, there is no loss of energy, but because of this collision, pressure is formed. And this is the pressure that you feel or sense when you have a gas container. So, a football or a cycle tube is having pressure because of the continuous rapid random motion of the gas molecules at different velocity causing collisions, not losing energy but giving rise to pressure because gas molecules are elastic and expand to occupy all the space available on that container. Now, what is the average kinetic energy per molecule? It is 3 by 2 kT, where K is the Boltzmann's constant and T is the temperature, given temperature. At different temperature or at a different pressure, this will be different. K is Boltzmann's constant. 3 by 2 kT is the kinetic energy per molecule of gas. Now, at constant temperature, the total pressure is the pressure of each of the constituents of the non-reacting gases, sum of the partial pressures, that is mole fraction into total pressure. Now, we know PV equals to nRT, we know kinetic energy is 3 by 2 kT. So, R by Na, what is Na? Number. Which number? Avogadro number. Na is Avogadro number. Will give 1.38 into 10 power minus 23 joules per Kelvin. PV equals to 1 by 3 mnu square. U is the root mean square velocity, which is can also be written as 3RT by M. 3RT by M. PV equals to nRT. So instead of PV, you write nRT, and then this 3 denominator will come to the numerator. It will become 3 nRT, and then it is M is the molecular mass. M is the molecular mass, square root of. Coming to liquids, conversion of gas to liquid is called liquefaction. Liquefaction or liquefaction is a process by which gases are converted to liquid. This is used for transporting gases usually. What are the critical temperatures? Critical conditions required for liquefaction is at any point in time you cannot convert water vapor into water. There are certain conditions at which this is possible. The maximum temperature at which a liquid can be liquefied is Tc. Maximum temperature at which a liquid can be liquefied is called Tc. The maximum temperature, minimum pressure at which a liquid can be liquefied is called Pc, pressure critical. Critical temperature is the maximum temperature at which a liquid can be liquefied. Pc or the critical pressure is the pressure, minimum pressure which is required for liquefaction of gas to liquid. Now critical volume Vc is the volume of one more unit of gas. Volume of one more unit of gas. And then we have a formula PV equals to 3 by 8 RT. PV equals to 3 by 8 RT. Now what is critical temperature Tc, the maximum temperature? That is 8 alpha by 27 Rb, where R is the universal gas constant. What is critical pressure? The minimum pressure required for liquefaction Pc is alpha by 27 B square, alpha by 27 B square. And what is critical volume? The one unit of volume or one more unit of gas, that is 3 times B. These are the relationship between critical temperature, critical pressure and critical volume. And PV equals to 3 by 8 RT, where R is a universal gas constant. Liquids are molecules that are held close to each other, not as close as solid but better more close than gas. They have random motion in the intervening space. That is why the liquids take the shape of the container. The substance is having a melting point below room temperature and a boiling point above room temperature is called liquid. Why you call it as a liquid? If the boiling point is at room temperature, it will boil and become gas. If the melting point is at room temperature, it will melt and the water will become ice. It is not becoming a solid, it is not becoming a gas, it is remaining as a liquid. That is why a substance having a melting point below room temperature and a boiling point above room temperature is called a liquid. A substance that remains as a liquid at room temperature is called liquid. What is vapor pressure? Vapor pressure is the pressure exerted by the vapors above a liquid surface when these are in equilibrium with the liquid at the given temperature. So, vapor will exert a pressure on the liquid surface when at equilibrium. It depends on nature of liquid and the temperature. Different liquids will have different vapor pressure. That is why different types of water boil at different levels. Boiling point is a temperature at which vapor pressure of the liquid becomes equal to atmospheric pressure. So the vapor pressure starts to make the liquid into vapor. At 1 atm pressure, boiling point is known as normal boiling point. At 1 bar pressure, boiling point is known as a standard boiling point. What's the difference between normal boiling point and standard boiling point? Normal boiling point is 1 atm pressure. Standard boiling point is 1 barometric pressure. 1 bar is for atmospheric pressure, 1 atm is the nanometric pressure. Surface tension. The force acting per unit length perpendicular to the imaginary line drawn on the surface of the liquid is called a surface tension. So on the surface of liquid, if you look at perpendicularly, and the force acting on per unit length perpendicular to the imaginary line drawn on the surface of the liquid is called the surface tension. That surface tension of the liquid, for example, for mercury it is different, for water it is different, for kerosene it is different. This is measured by stalgmometer. Stalgmometer. How it is measured? Gamma equals to force by length. Gamma equals to force by length. Kilogram per second square, Nm Newton per meter. Now comes the viscosity of a liquid. What is viscosity of a liquid? The resistance to the flow of the liquid is called viscosity. Honey is more viscous. So when you pour honey, it doesn't flow. Water is more viscous than the water is not as viscous as honey. So water will flow. The measure of resistance of flow due to internal friction between the layers of the fluid that prevent them from slipping past one another is called viscosity. Viscosity is the stickiness of the different layers or the resistance preventing one layer from another or the friction that doesn't allow free movement of the layers of a liquid is called viscosity. When there is a regular gradation of velocity in passing from one layer to another, it is called a laminar flow. When the upper layer and lower level, and then from there to still lower level, if there is a gradation in velocity, different layers flow at different speed, like a glacier, then it is called laminar flow. What is velocity gradient? Velocity gradient is the forces required to maintain the flow. F equals to N adv by dz. What is coefficient of viscosity? Coefficient of viscosity is the force when the velocity gradient is unity and the area of contact is unity area, one unit area. So, the force of velocity gradient is 1 unit and the area of contact is 1 unit area, then it is called coefficient of viscosity. Viscosity is the resistance of the flow due to internal friction between layers as they flow or slip against each other. Vapor pressure. Vapor pressure we have seen is a pressure exerted by vapors because of which the water will become vapor or not at a given temperature. Now in a pressure cooker there is more vapor pressure because it is closed and the water vapor inside remains inside. When you keep the lid open it takes more time to cook because the water keeps on becoming vapor and gets out and escapes into the atmosphere. So the pressure exerted by the vapor above the liquid surface when they are in equilibrium with the liquid at the given temperature, that is the vapor pressure, will be higher when it is closed and lower when it is open. It is the nature of liquid and temperature are the determinants. Now let's look at or have a look at solids. In solids, the unit cell, the particle, the smallest group of the lattice point, which when repeated in all directions forms a lattice. Unit cell is the smallest particle, structure or group of atoms. The smallest possible group of lattice points is called a unit cell. What are lattice points? The lattice points are the ones that give a structure for a solid so that when the lattice points or the unit cells are repeated in all directions, they will become a lattice. The dimensions are called A, B, C and the angles are called alpha, beta, gamma. Unit cell is the smallest group of lattice points which when repeated in all directions will form the lattice. Lattice is the structure of a solid. The dimensions are called ABC and angles are called alpha, beta, gamma. Now crystal lattice is an array of lattice points showing arrangement in constituents in different position in 3D. Crystal lattice means the arrangement of the constituents in different positions in a 3 dimension. There are 7 crystal systems: cubic, rhombohedral, orthorhombic, triclinic, monoclinic, tetragonal, hexagonal, etc. These are the various crystal formations in which the lattice points are arranged in a solid. What are lattice points? They are the arrangements in a 3 dimension of the constituent molecules which gave shape and structure to a solid. The dimensions are called ABC while the angles are named as alpha, beta, gamma in which they are arranged. The face-centered cell particles are present in corners as well as center of each of the faces. Then there is suppose it's a cube, the cell particles are present on the corners or the cell particles are present on corners and center or the cell particles are present on the center of the body as well as on the corner. So these are the different ways in which the cell particles, the unit cells are arranged in a solid. Some of them are primitive, that means only at the corners. In some solids, the spheres are packed differently in each of the formation or the structure. So some are only in corner, some are only in the corner and the center, some are in the corner as well as in the face of the cuboid. Now, the solids get their rigidity because of the strong forces of attraction among the constituent molecules. Solids get their rigidity because of the strong forces of attraction among the molecules. So that is why they have a fixed volume, they have a fixed shape. They are crystalline because systematic regular arrangement, repeated arrangement of the molecules, and they have sharp melting point. Solids mostly can be melted into liquid or gas. They are anisotropic, that is different values for physical properties in different directions. Anisotropic. Some of them are anisotropic, that means different values for physical property in different direction. Why? Because they are in crystalline, they have different properties. Molecular, like solid iodine or water. Atomic, like covalent, graphite, diamond, etc. Or metallic crystals, or they are ionic, like sodium chloride or zinc sulfide. So the crystalline nature of the solids or the systematic regular arrangement of the solids are molecular, atomic, metallic or ionic. They are also called sometimes amorphous. Amorphous means what? They are not systematic arrangement, they are unsystematic, they are irregular. The particle arrangements are irregular. When they are amorphous, they are isotropics. When they are amorphous, they are isotropics. When they are crystalline, they are anisotropic. Anisotropic means opposite of isotropic, anisotropic. When they are amorphous, they are isotropic. Isotopes are what? They'll have different behaviors. The physical properties are same in different direction. In crystalline, physical properties are different in different direction. Now, what is Bragg's law? Bragg's law says the interplanar solid structure can be measured using X-ray angle of reflection or deflection. When an X-ray is sent into a plane surface of a solid, the solid structure deflects and reflects the X-ray angle. Based on that reflection, we can determine the interplanar solid structure. That is why when you send it on a solid wood, send it on a solid granite, send it on a graphite, and when you send the X-ray on a diamond, the reflections are different. Even a small simple light, when it reaches a diamond, the reflections are different because of the crystalline characteristics, not the amorphous characteristics. What are the other features of solid? Solids are conductors of electricity, heat, and magnetic in property. What is magnetic property? Each electron acts like a tiny magnet. Number of electrons put together form a nucleus, and the nucleus is the center of an atom. All the atoms together form the element or the particle or the substance. So when each electron acts like a magnet, the atom acts like a magnet. That means the substance will act like a magnet. Why it is this? This is because of the orbital motion around the nucleus and spin around its own axis. Just like Earth spins and revolves, electron also spins and revolves. The orbital magnetic moment is called Bohr magnetron, BOHR. He was one of the pioneer in studying the atoms. Bohr magnetron. It says 9 into 10 power minus 24 ampere per meter squared. That is the orbital magnetic moment of an electron because of the orbital moment. The diamagnetic is what? Weakly repelled by magnetic field. No unpaired electron. It is called diamagnetic. What is paramagnetic? Paramagnetic is attracted by the magnetic field. Have unpaired electron. Diamagnetic have no unpaired electron. Paramagnetic have unpaired electron. Means what? The electrons are not in pairs. So it is either 3 or 7, something like that. So what it means? It means it loses magnetism in the absence of the magnetic field. Because it is paramagnetic or half magnetic and the electrons are unpaired, when it gets paired or when it loses a pair, it may lose magnetism in the absence of the magnetic field. That means what? Suppose you have a magnet and suppose you have a ferro material or an iron. The iron is paramagnetic because it will be magnetic in the presence of magnetic field. When you have a magnet, it will pull. But when there is no magnet, the iron will not get pulled. So it is paramagnetic. What is ferromagnetic? Ferromagnetic is it will be attracted by the magnetic field. It will show permanent magnetism even in the absence of magnetic field. Ferromagnetic means magnetism in the absence of magnetic field. That means what? It does not depend on another magnet to pull it. It has its own magnetic effect. It displays magnetism even in the absence of magnetic field. The property decreases from ferrous to nickel and decreases in the unpaired electrons. Then there are something called antiferromagnetic. What is antiferromagnetic? It has negative magnetic capacity. It has a moment zero. For example, manganese oxide. Compensatory alignment of the electron is the cause for this. These are the magnetic properties. Coming to conducting properties, the conduction is happening in metallic or solids because of the way in which the electrons are bound in the solid. We have metals, metalloids, semiconductors, etc. as a different elements which are solids. What is a semiconductor? Semiconductor is a semi-metal like behavior. That means it has a conductor like behavior as well as an insulator like behavior. When some impurity is added, it becomes conductor. That is like a metalloid behavior. Semi-metal or a gap between conduction and the valence is small. Gap between conduction band and valence band is small. Gap between conduction band and valence band is small. Because of this small gap, conduction is happening sometimes when it jumps and not happening when it is not jumping. So some electrons may jump to the conduction band and then it will cause conduction. Some electrons may not jump in the conduction band and so conductivity may not be there. That is why it is called semiconductor. This conductivity increases with the temperature. Conductivity increases with temperature. And this conductivity can be increased by doping. Doping means what? Adding impurity. That means what? Making the non-metallic behavior to become metallic behavior. Now, normally doping is done by adding group 15 elements. Doping is added by adding group 15 elements. Why? Because they have an excess electron or a p type, with the 13 elements having one short electron. P type is having one short electron. N type is having one extra electron. So N type having group 15 or a P type of group 13, because they have one excess electron or one short electron, it is easy to do the doping. So insulators are non-metals usually. And then we have variations like dipole or dielectric, and we also variations like piezo, pyro, ferro and antiferroelectric. Just like in magnetic we have a dimagnetic, paramagnetic, ferromagnetic, antiferromagnetic. In electrical conduction we have dielectric, dipole, piezo, pyro, ferro and antiferro as the characteristics of electrical behavior of solids. Thanks for watching this video. We were talking about the different characteristics of solids, liquids and gases, the states of matter as a part of basics of chemistry.